Hi, in this video, we are going to see how to convert a quadratic function from general form to vertex form, or it can also be called as standard form. Okay, first let us see what is general form of a quadratic function and vertex or standard form of a quadratic function. So y is equal to ax square positive bx positive c. So this is a general form of a quadratic function. Okay, so the vertex form or standard form of a quadratic function is y equals to a times x negative h whole square positive k. So this is called vertex form, or it can also be called as standard form. Okay, the second one is called vertex form because we'll be able to get the vertex of the parabola. So the graph of any quadratic function will be a parabola. So the vertex of the parabola, we can get it from the vertex form easily. That is, the vertex of this quadratic function is h comma k. So the value we have at the position of h is taken as x coordinate of the vertex, and the value we have at the position of k is taken as y coordinate of the vertex. So that's why this form is called vertex form or standard form. Okay, here we are going to see how we can convert a quadratic function from general form to vertex form. Okay, let's see that one with an example. Okay, just consider the quadratic function in general form, that is y is equals to x square positive 6x positive 7. Okay, here we have a quadratic function in general form. I just want to convert this one to vertex form. Okay, whenever I want to convert a quadratic function in general form to vertex form, I must be aware of the two basic algebraic identities. So they are a square positive 2ab positive b square equals to a positive b the whole square, and a square negative 2ab positive b square equals to a negative b the whole square. So here in the first one, the 2ab is positive. So on the right side, in the square of the binomial, we have positive sign between a and b. So here in the second one, the 2ab is negative. On the right side, between a and b, we have negative. So whenever we have a trinomial in the form a square positive 2ab positive b square, or a square negative 2ab positive b square, it will be called as perfect square trinomial, because a trinomial in this form can be written as the square of the binomial a positive b the whole square, and the trinomial in the form a square negative 2ab positive b square can be written as the square of a binomial, that is a negative b the whole square. So here, when I consider the vertex form of a quadratic function is a times x negative h whole square positive k. So this is the vertex form of a quadratic function. So this vertex form of a quadratic function contains the square of a binomial, that is x minus h whole square. So that's why I just want to use one of these two identities to get the square of a binomial, I mean this particular form. Okay, let's see how it is in our example. Okay, so on the right side, in the given quadratic function, on the right side, we have x square positive 6x. So let's compare this one with a square positive 2ab. So for a square, in our problem, we have x square. So instead of a, we have x. So here, I'm just comparing the first term with the first entity. The reason is x term is positive. So if I consider x square for a square, and for 2ab, we have 6x. So that means we have to write this 6x in the form of 2ab. So that means they have to write this 6x as a multiple of 2. Okay, so y equals to x square positive. Already we have compared this x square over here and the first term of the trinomial over here. So x, when I compare this x square and a square, I have x for a. So now I have to write this 6x in the form of 2ab. So 2 times. So since we have x for a, first I write x. Now I have to write some number over here. So the product of these three quantities, 2x and the number here, must be equal to 6x. So that I'll be getting the form a square positive 2ab over here. Okay, so what number should I write inside the parenthesis over here so that the product of these three quantities is equal to 6x? So it's very simple. We have to take 3. So 2 times x is 2x. 2x times is 6x. Okay, now clearly this is in the form of a square positive 2ab. Okay, so according to the first identity, we need b square, positive b square over here. Instead of b, what do we have in our problem? That's 3. So we need positive 3 square. So I'm adding 3 square. Okay, to compensate the addition of this 3 square, I am subtracting 3 square. At last, I'm taking this positive 7. So let me tell you the step, this particular step once again. First, I write this x square as it is. So since we have positive sign for 6x, I compare the first two terms with the first identity. So I have to write the first two terms in the form of a square positive 2ab. So I have to write this 6x in the form of 2ab. So that means I have to write this one as a multiple of 2. So first I write 2. Since we have x for a, I write x in. Then I write 3, so that the product of these three quantities will be 6x. So and then when I compare this one with this, it is in the form of a square positive 2ab. So in the identity, after a square positive 2ab, we have b square. So we need b square over here, but instead of b, we have 3 in our problem. So I'm adding 3 square to compensate the addition of this 3 square and subtracting 3 square. And at last, I'm taking this constant positive 7. So this is the original stuff. I have made some changes in the original stuff in order to get an expression in the form a square positive ab positive b square. But make sure the stuff in which I have made some changes must be equal to the original stuff. For that, you have to simplify the expression we have over here. So we have x square, x square. So 2 times x times 3 is 6x. And positive 3 square, negative 3 square is 0 pair. And we have positive 7. So the stuff we have over here is equal to the original stuff. Okay, now here consider the first 3 terms of the expression over here. So this is in the form of a square positive 2ab positive b square. So I've already told you, whenever we have a trinomial in this form, a square positive ab positive b square, it can be written as the square of a binomial, a positive b the whole square. So in our problem, instead of a, what do we have? Instead of b, what do we have? Instead of a, we have x. And for this 2ab, we have positive sign. So I have to take positive sign over here. For b, I have 3. Then I have to put whole square. So I have written this x positive 3 the whole square for this expression. So then the rest is negative 3 square positive 7. The value of negative 3 square is negative 9. Then we have positive 7. So many students will misunderstand. Since we have square for this 3, they will try to make this negative sign as positive. Actually, it's not correct, because if you have negative 3, the whole square means, so the square we have over here is applicable for both negative and 3. So when I apply this square for this negative sign, it will become positive. When I apply this square for this 3, it will become 9. So here in our problem, we have negative 3 square. So the square is applicable only for 3, not for this negative sign. So we get, so this negative will remain same. The value of 3 square is 9. So we get negative 9. Okay, now let's simplify this. So y equals to x positive 3 the whole square. When I combine negative 9 and positive 7, I'll be getting negative 2. So the vertex or standard form of the given quadratic function is y equals to x positive 3 the whole square negative 2. Okay, let's look at another example. Okay, here we have a quadratic function in general form, that is y equals to x square negative 5x positive 12. Okay, the same thing what we have done in the previous example, we have to do in this one also. So first, let me take y equals to, I've told you in the previous example, we have to write the first two terms in the form of a square negative 2ab. So here I consider the second identity, because here in this case, x is negative. So I consider the second identity, because in the second identity, 2ab is negative. So first I write x square. So comparing this with a square, so we have x for a. So we have to write the middle term, that is 5x, in the form of 2ab. In the previous one, the x term was a multiple of 2. So easily we wrote the x term in the form of 2ab. But here, 5 is not a multiple of 2. What do we have to do? Anyways, we must write the x term in the form of 2ab. So first, let me write 2. And then I have to write a. For a, we have x. So what number should I write over here so that the product of these two quantities is equal to 5x? So it's very simple. We have to write 5 over 2 over here. 5 over 2 here. So now if I multiply 2x and 5 over 2, what do I get? That's just 5. That is 2 times x is 2x times 5 over 2. So this 2 will cancel out. When I multiply this 5 and x, it will be 5x. Okay, now this expression, that is x square negative 2 times x times 5 over 2 is in the form of a square negative 2ab. So for b, we have 5 over 2. Now we need b positive b square. So I'm adding 5 over 2 the whole square. Because 5 over 2 is the value we have for b. Since I need b square, I'm adding 5 over 2 the whole square. So to compensate the addition of this 5 over 2 the whole square, I subtract 5 over 2 the whole square. Okay, now I'm taking this constant term at last, positive 12. Okay, in the given stuff, I have made some changes. Please make sure the expression we have over here must be equal to the original expression we have on the right side of the given quadratic function. So x square, already we have checked, that is 2 times x times 5 over 2 is equal to 5x. And also this is 0 pair, and we have positive 12. Okay, now the first three terms of this expression are exactly in the form of a square negative 2ab positive b square. So whenever we have a trinomial in this form, it can be written as a minus b the whole square. So we can write this expression as a square of a binomial. So for a, we have x. For b, we have 5 over 2. Since 2ab is negative, we have to put negative over here. So x negative 5 over 2 the whole square. So the square of this binomial is equal to the expression we have over here. Negative. So here 5 out to the whole square. That means, so this is a common exponent for numerator and denominator. If I distribute this exponent 2 to numerator and denominator, it will be 5 square. 5 square in numerator, it will become 25. And 2 square in denominator will become 4 positive 12. Okay, so y equals to x negative 5 over 2 the whole square negative. Okay, now to simplify this negative 25 over 4 positive 12. So what I'm going to do is I'm going to multiply this integer 12 by the denominator 4. Once I'm done with this multiplication, I can take this 4 as a common denominator. That is negative 25 positive 4 times 12 is 48 over 4. So y equals to x negative 5 over 2 the whole square. Okay, now if I combine negative 25 and positive 48, it will be positive 23 over 4. So now this is in vertex form or standard form. So the vertex or standard form of the given quadratic function is y equals to x negative 5 over to the whole square positive 23 over 4. Okay, let's look at one more example. Okay, here we have a quadratic function in general form, that is y equals to 2x square positive 12x negative 7. Okay, in the previous two examples, we don't find any number in front of x square. I mean, the coefficient of x square was 1 in the previous two examples. But in this case, we have a different number, that is 2, which is being as a coefficient of x square. Okay, until we have this number 2 in front of x square, it's a bit difficult to compare the first two terms with the trinomial we have over here. So we have to get rid of the number that we have in front of x square. So if it is 1, we don't have any problem. Whenever we have a number in front of x square which is other than 1, so our first work is to get rid of that number so that we'll be able to get a trinomial in this form. So we can write that one as a square of a binomial. Okay, so to get rid of this number 2, what I'm going to do is I'm going to factor 2 out from the first two terms. So now you should not factor this number from all the 3 terms of the given function. You have to factor this number 2 out only from the first two terms. And here you may have a question. We can factor x also out because both of them are multiples of x. So we can factor x also out. No, don't factor x out. So you have to factor only this number out. So to get the given quadratic function in vertex or standard form. Okay, so I'm going to factor this 2 out. Now, to get the expression inside the parenthesis, what I need to do is I have to divide the first term and second term by this 2 because I factored this 2 out from the first term and second term. Okay, now I'm going to divide this 2x square by 2. So what will happen? This 2 will cancel out. I get x square. Then I divide positive 12x by 2. So 2 goes into 2 1 times. 2 goes into 12, 6. So I'm getting positive 6x negative 7. Okay, from now, the process is similar to the previous two examples. That is x square. So now we can compare these two terms with the square of the trinomial we have over here. So because here x is positive, that's why I consider the first one. And the first one, the sign of 2ab is positive. So I have to write this x square positive 6x in the form of a square positive 2ab. So then we get 2 times. For a, we have x. So 2 times x times I have to write 3. So that this product is equal to 6x. Okay, now instead of b, we have 3. So I need b square. So I'm adding 3 square. So to compensate the addition of this 3 square, I subtract 3 square. I close the parenthesis. So I have done this work only for the stuff we have inside the parenthesis. Okay, even if you simplify the expression we have inside the parenthesis, it has to be equal to x square positive 6x. Okay, let's check it. We have x square and x square. So the product of 2x and 3 is 6x. And this is 0 pair. So this is equal to x square positive 6x. Now we can take this negative 7 at last. Okay, y equals to 2 times. Okay, this, I mean, the first 3 terms, x square positive 2 times x times 3 positive 3 square are exactly in the form of a square positive 2ab positive b square. So we can write this expression in the form of a positive b the whole square. For a, we have x. And since 2ab is positive, we take positive sign. For b, we have 3 the whole square. I am writing this x positive 3 the whole square for this expression because this expression is in the form of a square positive 2ab positive b square. Okay, now so negative 3 square, which will become negative 9, negative 7. Okay, now we can distribute this 2 to this one and this one. When I do so, I'll be getting 2 times x positive 3 the whole square. 2 times negative 9 will become negative 18, plus we have negative 7. Okay, now we can combine these two values, negative 18, negative 7. When I do so, so y equals to x, 2 times x positive 3 the whole square. When I combine negative 18 and negative 7, it will be negative 25. Okay, now I got the vertex or standard form of the given quadratic function. So that is y equals to 2 times x positive 3 the whole square, negative 25.